Hey, it works. Cool.
This is an old notebook. Nice because it's graph paper.
Sounds like everybody can hear me. So we're gonna get started shortly.
Then how do you find out the names of the previous 500 employees that came before you? You probably can't. Okay.
Where's James? Where's Dennis?
This would be the first time anybody RSVP'd and never showed up. Come on.
Maybe I stick a whole pizza hole with them tonight.
We'll get started here in a sec. So I took over the group last month.
All hail.
So obviously this is the last one of the year. Because the next meeting would fall on January 2nd, I'm gonna skip January. I don't have a speaker lined up quite yet anyway, so we're gonna skip January. We'll shoot for February, whatever the first Tuesday in February is. I'll line something up for sure. If you know anybody who's speaking, or you want to speak, or you have any ideas of something cool that would be cool to see, let me know. I'm thinking I would like to have somebody come in and present on one of the newer JavaScript frameworks, preferably Vue.js would be a really cool one. Like to see maybe some more mobile stuff. I know Microsoft has been pushing a lot of the cross-platform, not just Xamarin, but kind of the whole ecosystem around Xamarin, and kind of more of the, I know they do kind of dipping their toes in React Native, and I don't think we've had anybody come and present on React Native or anything like that either, so that would be pretty cool. Server-side stuff, I don't know if we've had anybody come in and do like a server-side Node.js framework or anything like that. Would be really interesting. Some lower level stuff, WebAssembly, or yeah, really any lower level stuff would be cool too. Do some Ada. UWP is probably still teaching it too, and that's probably why they taught it. So yeah, gonna try and fill a calendar up for next year. Sounds like we might have one more coming in, and then we will get started. Dennis. We'll get started here in a sec. Okay, so by show of hands, who's heard of reactive extensions before? Who's used reactive extensions before? So not many. I know that, yeah. I work with Kevin at Cartograph, and we have a mobile app that uses Angular 2, Angular 2's HTTP service, and a bunch of the other stuff that's provided by Angular is based on RxJS. And so we're going to kind of talk about RxJS and Rx.net today. Promised I would talk about RxJava, and I have a really cool sample, but there's so much stuff that I want to try and cover that I kind of just push that away. So if you're here for Java, there's the door. You can head out now. So for those of you who don't know, and I think I know pretty much everybody in the room except for, what's your name again? Nathan. So I'm Cody San. I work at Cartograph out in Key West. I also run a software development consultancy called SandToken. Doing a little bit of RxJS lately, but particularly my expertise is that I've been working with Manning Publications on a couple of books. So there's Rx.net in Action by Tamir Drescher, and there's RxJS in Action by Paul P. Daniels, and I served as a technical advisor on those. So basically they wrote the book, I went through and verified the technical accuracy on the books. There's a third one that's coming out called Grokking Functional Reactive Programming. That one's based on Android, uses RxJava. I was the technical advisor on that one too. And so I haven't used I haven't used RX on like a massive scale or anything like that, but I do have a very good handle on the framework. I've used it in production applications, and so teaching you the fundamentals, I'm hoping won't be a very hard task. So get started here, hop right in. If I can get my remote going. So in the beginning there were callbacks, right? For those of you who have been working with web programming or any sort of, really any sort of user interface application programming, you've found an event handler, right? And you've had a callback. And so the thing with callbacks, as you start to stack those callbacks and you need a callback within a callback, you start to see this nesting effect. And so this is a very light offender, right? We're about 3 levels deep in my console.log where I'm logging the result of this get stuff by category, going and getting my tools. And once I get my tools, I've got another function, my callback function here. I'm going to take those tools and I'm going to sync some stuff with a local database and pass my tools in. And then once that's done, I'm going to get some result back from that operation. I'm logged to the console. It's a pretty common process that we do in web programming. So from there, and I'm going to skim over this stuff really quickly. So you've got the callback approach, and that has been dominant in JavaScript for a very long time, since its inception up until maybe 5 or 6 years ago, until this newer concept about promises call out. And so some languages call these futures. This is basically the idea that you're going to get a way to say, hey, you're going to go do something. I don't know when you're going to finish, but you can let me know when you're done. And so in JavaScript, that it breaks it down like this instead. So I've got my get stuff by category. I'm passing tools. And then, as you can see by the function call, then I want to do something else. And when that's done, I want to do something else. And so this allows you to kind of start chaining your it's almost like a pipeline of what you're doing here. I need to do this, then this, then this, then this, and I'm done. Without all of the nesting. So you're not, as you're adding more callbacks, you're not kind of nesting further and further and further down in the code. That affects readability of the code, which results in bugs and maintainability issues, which is a whole other topic. But so promises are really cool, and they're really good about helping you clean up those really nasty nested callback structures, but they're not the end-all be-all of asynchronous event handling. So why not? So first of all, they only represent a single asynchronous future event. So one event in the future is going to happen, right? So if you have something that's going to be, think of like a stock quote. You want to keep getting stock quotes as they're coming off the ticker, right? You have to call every time. So you're doing more of a polling operation, saying, hey, go get me the next value. Hey, go get me the next value. Hey, go get me the next value. It's a little bit of a limitation, right? You can still work with it. You can still sit there and poll that source, but we're going to show you a better way. Second, one of the the weird dark corners of promises is that by default, if an exception gets thrown in the promise, it gets swallowed and you see nothing. So you're not going to see an error in your console as you're trying to develop your software. I spent days trying to narrow down one of these issues not too long ago, where the promise, when it blows up, I didn't see anything. I didn't hear anything. You get no notification at all. And so I've got a link here that kind of dives a little bit deeper into that topic. I'll post these slides out on the meetup when I'm done. But that's one of the big pitfalls for me. That when I encountered that issue and I figured out what that was and kind of wrapped my head around it, it put a bad taste in my mouth about promises altogether. So I avoid them. From there, you got the basics, like you can't really cancel a promise. You can't, beyond like saying, okay, do this, then this, and this, and this, you can't really compose them together. And that'll make more sense when I talk more about the observables and composing the observables in RxJS. Like I said, limited support for transformation, and the promises are really kind of JavaScript centric right now. Big on the web client, not really all over the place. There's a spec that's out there, but it's really JavaScript specific. So reactive extensions, kind of the next generation of async event handling, right? So async event handling, an interface for async event handling, like I've said, but it's more functional, right? So what does functional mean? It means it's more declarative. You're not necessarily speaking of terms of how you do something, but more about what you want at the end of it. They're composable, meaning you can take sources or multiple sources and merge them together. You can transform the data. You can kick off asynchronous operations based on every piece of data that's coming through the stream. A whole bunch of stuff that we'll get into. Focus on immutability and pure functions, meaning that trying to keep your software side effect free, right? I'm gonna show you, we construct these pipelines of processing these events or these asynchronous things, and making sure that there's no global state associated with that. There's rarely even like function scope state around that. Really just kind of, you declare these pipelines of how you want your events to be processed, and it just kind of goes through, and it all just works. It'll make a lot more sense when we dig into the code. So they're lazily evaluated. What that means is when you're working with something, if you think about working with an array that has trillions of items in it, right? Not possible. There's not memory out there, and our consumer level machines to handle an operation like that. Well, reactive extensions are lazily evaluated, so you only are allocating the memory for the pieces that you have, right? So if you've got an array of 1 million things, you only need that one, and then you're done with it. You take the next one, you're done with it. So you never have to go to the end and like scoop all of these pieces up. You just take them one by one from the framework. Better error handling. It's less opinionated than the promises, and it's cross-platform. So I'm going to dig a little bit deeper. Where can you use it? All the languages you see here. We're going to do JavaScript and .NET today. It's on Java, C++, Python, Go, Ruby, PHP, Swift, Scala, etc., etc., etc. The Reactive Extensions project, or I guess group, is the repository. The group on GitHub has a repository for every language. So it's all maintained by kind of that same group. They all adhere to the same interface, while continuing to respect the platform-specific idioms that you might encounter. So like in JavaScript, method names are generally start with a lowercase letter. Well, in RxJS, all the methods start with a lowercase letter. In .NET, .NET provides like the iDisposable interface that objects should inherit if they need to be disposed. Well, RxJS also makes use of that interface. Obviously, he's not going to do the same thing in JavaScript. There is no iDisposable interface. But he, like I said, respects the platform-specific stuff in each of the frameworks. That's a slide I didn't finish. Microsoft obviously uses RxJS, Netflix. Trying to remember the other ones, but it doesn't really matter. So now that we got a brief intro, and just kind of walk you through the fundamentals. The fundamentals they're almost so simple that you like don't believe it. But they enable a great deal of power when you learn to kind of start constructing these things together. So at the top level, we're generally working with what are referred to as iterables. So here I've got like an array of values. So that's something that I might have allocated in memory. I know that there's 5 items. I know I'm only going to ever have 5 items. They're all right here. I've got them. That's versus a stream of values, which moving left to right, you've got a kind of a time representation, and so you might get one value within the first second. It might be another second before you get values 2 and 3. It might be another second before you get values 4 and 5. And then this line indicator, and we're going to talk about these marble diagrams a little bit. This means that it's done. So the stream, I got 5 values, but the stream is kind of those same 5 values over a time representation, right? And so, a lot of those times they're just going to be bing, bang, bong, coming right through the pipeline. A lot of those times, with a stock ticker, if you're monitoring single stock or whatever, you're not necessarily going to have a steady pattern of values coming into your stream. And so, again, to kind of contrast with some of the other ways of handling asynchronous results, they call reactive extensions more of a pull style of operation. So, or sorry, not pull, push. Old style is pull, new style is push, meaning that you're going to set up these pipelines and say, hey, I want to listen to click events, or I want to listen for this, that, whatever, and those values are going to get pushed to you. You don't have to ask for them. You just set this stream up, and the call or the observable that you're going to subscribe to, whenever he has a new value, whenever that stock ticker gets a new value, he's going to send it to you. And so it's more of the source is sending you the data versus you are asking that source for that data. So in .NET, this is a kind of a good way to think about it. In .NET, when you're kind of working with, oh, I'm making a function call, or I'm doing some operation where I want to retrieve a value. If it's a synchronous operation, you're just, if you call toString, you're getting a string back right then and there. There's no asynchronicity about it. You call object.toString, you get whatever that value is, toString. With synchronous and you're working multiple values, you're talking IEnumerable T, right? So your list of T, or your whatever your favorite IEnumerable implementer is. When you've got synchronous values and you need to iterate over that collection, IEnumerable T is what you're using in .NET pretty much all over the place, right? So then .NET, started adding async stuff. So if your toString is an async operation that needs to go do something, some file I/O or whatever, you can think of, they call that a task of T, right? So you're sending it out, and you're going to get a single value back of type T. It's going to come back at a later time. It's asynchronous. You don't know how long it's going to take, but ultimately what you're going to get back at a later date is of type T. Reactive extensions kind of fits in that last corner then. So the asynchronous and multiple values. So again, you're going to set this up one time. You're going to say, watch this observable for these events. The observable is just going to keep feeding you new events as that goes. JavaScript's kind of the same thing. I'm using roughly TypeScript annotated, or TypeScript types here to get your T. For multiple items in synchronous, you're going to have your T array. Async's going to be your promise of T, which we talked about just a second ago. Observable kind of, again, takes that to the next level, supporting multiple items. Some basic code here. So there's the two big things, and these are kind of the core interfaces of the whole thing, are the observer and the subscriber, or the, I got a typo there. This should be observable and subscriber. So on the .NET side, your iObservable is anything that implements the subscribe function, right? And so he takes an observer, and I'll explain that in a little bit. There's the iDisposable interface I talked about before. But so if you've got a source of data that's going to emit values to you, that's going to be an observable. You've got one of those sources in your code. You say, hey, source, I want to get data from you. You're going to call the subscribe method. And what you're going to do is you're going to specify this observer. The observer is three things. It's an uncompleted handler, meaning when the source of data says that I have no more data, I'm never going to have more data, I'm done emitting data, that's your callback. On error, I think, is self-explanatory. If any error happens during the processing of that pipeline, he's going to throw an exception, and you're going to receive that. The on next is the big one, though. So if I've got a source of data, and so think of that stock ticker. He's got new values coming in all the time. Every time that he's emitting a new value, he's going to call my on next. So I have a next value, so he's going to send it to me, and then from there I can process that however I need to process that stock price. I can make decisions on whether I should buy the stock or sell the stock or do whatever I'm going to do based on the data that was just pushed to me. And so those are kind of the three big things. You've got a source of data. You can say, hey, tell me when I get a new value, tell me if you get an error, and tell me when you're done. A lot of times all you're going to subscribe, when you subscribe, all you're going to say is, hey, tell me when you get a new value. I don't care when you're done, and maybe I don't even care if you have an error. I just, most of the time, just want to know when you're going to give me a new value. So on the JavaScript side of things then, got the subscriber of T, those same three things, right? The on completed, the on error, and on next. We've got the observable T here with the subscribe function. He takes the subscriber as described up above. Then he uses this interface called subscription. And so in .NET, it's called dispose when you want to get rid of the subscription. In JavaScript, it's called unsubscribe, and so that's kind of one of the minor examples, but most obvious examples, kind of how it's not always the same code, I guess, when you're writing RxJS versus RX.NET, right? In some place on RX.NET, you're going to be calling .dispose, and RxJS, you're going to be calling .unsubscribe. But the docs that are out there for reactive extensions do a great job of when you're looking up any of the stuff, he'll show you, oh, well, you're on RX.NET right now, but here's the one for RxJS, here's the one for RxRuby, here's the one for RxPHP, so on and so forth. And so one other thing that you're going to encounter that, I'll call fundamental is these marble diagrams. And so we spoke earlier about this being kind of a timeline, right? So things are happening from the past into the present, right? And so a good way to think about the RX stuff, these are observable streams, right? So maybe this is a stock ticker. This isn't really necessarily a good example, but we've got a quote come in at $20 or $40, $60. So we've got two streams here, and one of the things that I said you can compose streams. So this is one operator called merge that I'm just using as an example here. What merge does is he says, okay, if you've got two observable streams, so two sources of data that are bringing in values, right? Just take those two and turn them into one. So here you can see that he's emitting quotes at 20, 40, 60. Ultimately, when they get emitted through, so they process through the pipeline top down, time moves from left to right. And so we've got those values when 20 is emitted. Oh, well, 20 comes through, 40, 60. And so in this case, this is more about taking multiple streams and merging them into one, but maybe there's a double one here that'll take the 20 and turn it into a 40, or turn the 40 into an 80. And I'm going to walk through a bunch of these operators. That's where we're going to spend a bulk of our time today, just talking about the different ways you can go about, once you've got a source of data and it's emitting values, what can you do with those things that's interesting? And while I'm thinking about it, I need to boot up my Windows VM. It's going to take a second. So let's talk more about those observables, right? So they're the source of the activity. They're the source of the data. They're giving us everything. And they do that by emitting events or emitting values to subscribers or observers, like we talked about. Examples, a keyboard key being pressed, the mouse being moved, an HTTP response being received, your geolocation being updated from a GPS. It could be anything that's not happening the second that code is running, right? So you're saying, go watch my user via GPS and let me know when he's moved more than a mile. So you can set that one pipeline up. Your application just runs, doing its thing. Doesn't matter. Oh, hey, I just noticed that your person just moved a mile. Well, now I'm going to continue that pipeline, right? So here I've got a simple example. So to connect to an observable, you call subscribe, like I mentioned. So this is the JavaScript example. I'm getting some observable from give me some observable function. We don't know what kind of data this is, just whatever. I'm going to subscribe and say, anytime you give me a new value, go ahead and just log that to the console. I don't know how he's getting the data. I don't really care how he's getting the data, but now I've set it up so that whatever he's doing behind the scenes, whenever he gets a new value, he's going to send it to me, and I can log it to my console. If you've used I know that a bunch of us have used Knockout.js. The observable from Knockout.js kind of operates very similarly in that you're calling subscribe, you set up a callback function, you need to unsubscribe and clean up that memory when you're done. To cancel or stop listening, call unsubscribe. That's the gist of, hey, I've got a source of data. I want to be notified when that source of data has a new value. And when I'm done, I can throw away my subscription. So we talked a little bit about on next, on air, on complete. And so one of the subtleties about the the reactive extensions is, yeah. So he supports these three operations, but yeah, it's perfectly valid for an observable to only call on next and never call on complete. It's just as valid for him to only call on complete and never call on next. He might never call anything. He might never call any of those functions. And so setting the subscription up and setting the pipeline, I keep calling them pipelines, and it'll make more sense when I go through more code samples, but setting those up doesn't necessarily mean that anything's actually ever going to happen, right? This is asynchronous, so we don't know when it's going to happen, and just by nature of not knowing when that's going to happen, it means that it could never happen. So on next is going to be called ultimately 0 or more, I mean up to infinity times. Like I said, if your application can handle those values coming in forever, it's just going to keep coming in forever. We're not allocating more memory to keep storing those values. They just come through, we do what we need to do, and then we throw away the result. On error is going to be called, again, 0 or 1 times only. On error, it gets called, you're done. The source no longer emits any data. It closes up, and you're completed. Again, same thing for on-complete then. When that stream says, I'm done, I don't have any more data, he means it, that you're not going to get any more data. And so for subscriptions that complete or error out, you don't need to unsubscribe those, just a minor tidbit. But it is kind of weird that, yeah, on next can be called infinity times, and these things are only going to be called once, but if one of them fires, the other one won't fire, and so it gets a little hairy. But here's a clear example of kind of setting one of these up then. So got my give me my observable again, and so I'm just setting up 3 callback functions, just on next, on error, and on complete. All I'm doing is logging the new value. If I got an error, I'm logging that. Otherwise, time to clean up, right? So same thing, got my observable, dot subscribe, and I'm just passing those 3 parameters right in.
If in the far distant future, like 2 seconds later, you have a reopened event session or observables coming in, would you have to essentially resubscribe for those?
So yeah, when you subscribe to the observable, he's gonna emit. If he finishes, he's gonna call on complete, and you can in your code handle that accordingly. I guess once and I'll talk about this too, but nothing happens. There's nothing happening usually in the background with this observable. This is totally static. There's nothing. It's not processing in the background right now. It doesn't do anything until you call on subscribe generally. So if this is going to call out to the stock ticker and start receiving streaming quotes, that isn't going to happen until after you step across this line, right? This is just the setup.
Mm-hmm.
This is when it says, okay, now go, and start listening to the stock ticker and everything. Did that answer your question?
Yeah, in other words, you essentially have to go through your logic of opening up again, more or less.
Yes.
Okay.
Yep. Yeah. If that completes, he's done, and you would need to
No,
resubscribe. And yeah, when we go through the operators, there's actually utility operators for if something throws an on error, you can have your code retry automatically. Stuff like that. There's a lot of error handling type stuff. We'll talk about that when we go through the operators, which we're going to do right now. So the operators, if we step back here, yeah, I guess this is good enough. So right now I'm calling subscribe, and my new value, I just take that as is, right? Think about if that's a number, if I'm getting an error code back and I need to transform that, or I need to swap that out for its readable string, right? Where do I do that? I can do that here in my code, like in my callback function, but then anybody else who wants to do that same thing needs to also implement that in their callback function. So reactive extensions allows you to, again, set up, I call them pipelines. So this is just the beginning of the pipeline. He takes that value, he puts it into the pipeline. From there, as we go through these operators, you can see that tons of stuff can happen between the source got his information and is now giving it to me. Maybe he takes that number and swaps it out for a readable string error code. Maybe he squares the number with itself. Maybe it's a string and he makes it all uppercase or all lowercase, or strips out all the spaces, or does any sort of transformation. Those are really basic, but we'll kind of go through them here. So off the bat, you need some way to create observables, right? You can't just go out and download stock ticker.observable, whatever, and just drop that in your JavaScript. You have to, a lot of times you have to do the wiring yourself. So you have asynchronous stuff. You need to basically tell RxJS how to handle that stuff. And so I'm not going to go through all of these, but I do want to go through a couple. So create an observable. That allows you to create your own custom observable. That most of the time is like a last ditch. Like, okay, there's no way I can there's no other way for me to convert this into an observable, and so now I need to do all of the wiring by hand and do that. So while you'll do that sometimes in RxJS with the number of operators that are already out there and the number, it's very rare that you actually have to wire up your own stuff. So I'm trying to think of a good way to go through these, because just not. I guess, the timer and the start are good ones. Actually, I want to do interval. So think about in your application, you want to do something every 5 seconds, right? There's a number, we all know there's a number of different ways you can get a trigger every 5 seconds. But again, what is that? That's just some notification from somewhere else that says, hey, 5 seconds has passed, right? And so Reactive Extensions makes that really easy to set up. You can literally just say observable.interval, and then tell him how long you want it. He gives you a timer right then, and it's all observable pipeline and everything. And so it's really easy to say, okay, I got a 5 second interval here. What do I want to do every 5 seconds? Then you can maybe want to, maybe, I'm having a hard time coming up with an example. What do people want to do every 5 seconds in their code?
Save that.
Yeah, maybe like an autosave kind of function, right? You're editing your document and you're gonna, I guess most of the time you'd be waiting until after 5 seconds. And I actually have an example where, say, you're typing into a search box, you want to wait 750 milliseconds until after they're done typing before you kick off the search, right? Reactive Extensions makes that really easy. Maybe I'll just dive right into that quick before we hop right into the observables. Yeah, let's do that. Make this a little bit clearer. Readable, good enough. All right, so this is my RxJS example. So all I've got at the top here is the search Wikipedia function. I'm using jQuery's Ajax to just make a call to their server, right? They've got an autocomplete API. Just getting, if I type Cody, he's gonna give me all the first 10 pages or whatever that he would recommend if you were typing Cody in the Wikipedia search box. And so I'm gonna convert this to a promise when I'm done. So by default, the jQuery Ajax implements it implements a very close spec to the promise. The promise will give you the actual promise. The reason we get the promise is because RxJS already knows how to take a promise and convert that into an observable. So we're going to call out to the server, and again, in this case, it's just a single response that we're getting back. I've got on my Windows Forms example, I've got better examples on there. So call out to Wikipedia, give me a promise. That's kind of the smallest part. I've got 2 text boxes, and we got my input and my result. We kind of just look over here. Got this. If I type in Cody, it's going to wait 750 milliseconds, and he's going to fill in all of the suggested search terms from the Wikipedia API. So how does it do that? So up at the top, rx.observable.fromEvent. So this is a helper that's in RxJS. In JavaScript, there's events all over the place. There's events in the DOM. There's events in just the JavaScript, the HTML5 SDK or APIs. But so we're going to start off with just, go take my input text box and listen for the key up event. So that in and of itself, you can call .subscribe to. Just, go listen to the event, .subscribe, give me the event object every time. That would be the most basic kind of pipeline that we're talking about. Listen to the event, the key up event in the text box, and give me, when the event emits, there's an event object in JavaScript. It's got a whole bunch of information. What was the target element that fired this event, and a whole other bunch of context. But so next step, I'm going to use the map operator. I don't want the whole event object. There's a bunch of crap on the event object that has nothing to do with my application. All I want is the value, right? So go find the target of the event, which is going to be my input, and give me the value. What's the value of the text box now? Again, you can, if all you want to know is the text box value changed, you can set up .subscribe right here. Just listen to those events. I'm taking it a little bit further. So we're going to project the text from the input. So we're going to take that event object, we're going to strip away everything, and just pull that one property off, the value, the actual text value in the text box. From there, I'm calling the .filter operator. So again, taking my text, and I'm saying text length is greater than 2. So again, here I'm further narrowing my funnel, right? I'm saying, okay, well, go get these things and now filter them to only the ones, only let me know if the text box length is greater than 2, right? So we don't want to search the Wikipedia API for just 1 or 2 characters. We want there to be a minimum of 3. So again, I can set my subscribe here and just get notifications of when that happens. But in this case, I'm going to say, okay, well, as you're emitting those events, I'm going to debounce that. And so this is kind of like a throttling technique. Wait 750 milliseconds after the last time that was emitted. So if you got a bunch of them coming in, so I'm typing CODY, waiting 750 milliseconds elapses, and then finally that triggers. So this is just another filter that says, okay, well, if you have a bunch of key presses coming in, don't trigger anything until 750 milliseconds have passed. From there, we take it one step further, and we say distinct until change. So for whatever reason, this pipeline is kicking off for the same text that I just had, it ignores it. So it's not going to send multiple requests up to the Wikipedia API for the same search term. And so that's my observable, right? Go to my text box. Anytime there's a key up event, go get the value of the text box. If it's greater than 2 characters, fit 750 milliseconds for another event to come through. If no other event comes through, and it's distinct from the value that we last received, we're going to go ahead, and so I'm using this switch map. And so this is one thing. This is more of just like a, hey, listen for all this stuff, and if all these criteria are perfect, I've got a term to work with, right? The switch map allows me to say, okay, I'm getting a value from an observable. Now take that, and I want to switch over to another observable. And so in this case, I'm saying go switch Wikipedia. So I'm taking that search term that I'm getting, so text comes through. These aren't doing necessarily anything with the value that I'm getting back. They're just they're changing how the pipeline works, right? So wait 750 milliseconds and only tell me if it's changed from the last time that we got to this point. When that happens, go to Wikipedia and search the API. He's going to get the response back, and so again, here's my subscribe. Up until here, nothing's happened. We've never called Wikipedia API. We haven't called any callbacks. It's not until we call subscribe that all of this stuff gets hooked up. So we're not even listening to the value in the text box until the subscribe is called. This is what says, okay, you've declared, again, this is declarative, you've declared everything you want, now it's time to put it into action. So then go ahead and hit subscribe. He starts listening to the text box. We go back over here and we say Dubuque, and we get all of the suggested results there. So this is where the power of RxJS comes in. It's not from just saying, oh, hey, I've got an event source and I want to know when those values are coming in. It's this rich ecosystem of these operators that you can literally do anything that you could ever imagine as far as transforming data. There's so many clever things in the list of operators that you would never have thought about like ever needing, but they just sound really cool. Like just the power that they enable is ridiculous. So now that I've kind of gone through a quick code example, I want to kind of go back here. So this is, when I talk about creating an observable, you're not always necessarily saying, okay, go document.add event listener to this guy and wire up my observable all by hand. RxJS comes preloaded with ways to take async things like key up events of text boxes and automatically just convert those to observables in one line. So that's more a matter of just kind of learning the fundamentals, I guess, the ways that you're going to build those up. So I'm going to hop back in here. So in that instance, I was doing a key up event. I could swap that out for an interval, say, hey, every 5 seconds, go check the text box and see what the text is and do that, right? And so that's kind of what I was getting at when I was talking about doing everything 5 seconds. When you're doing something like a key up event, it's very clear when that's going to happen, right? The user's hitting their key. The interval is just a different way of solving that problem. Arguably, the key event is the one you're going to want to listen to in that one use case, but the option's there. So yeah, there's observables.from, and so not you just by nature of when you're working with asynchronous code, not absolutely everything is going to be asynchronous. A lot of times you're going to have the value, and you just need to kind of like treat it like it's asynchronous. Treat it like you went somewhere and got the value. So there's stuff like observable.from, where you can just say observable.from7, and it'll just give you an observable that emits the number 7, and that's it. Sounds weird, but when you start building a lot of your logic in RxJS, everything needs to be RxJS. And so just kind of something that kind of is very invasive, but it really cleans up the code when you are, you're really condensing it down in these declarations that are being put together that kind of drive everything.
So it ended up taking up the whole dirty word, WCF. Does it end up taking over a lot of the syntax in WCF?
So I'm gonna go. I have a .NET example where I'm making it like an asynchronous HTTP call. The same Wikipedia example. There are a lot of utility functions provided, especially by Rx.NET, as far as because one of the big things that when you first kind of start diving into Rx.NET, and if you've ever built a WinForms application, you try to have something process in the background thread and then reach back and update the value of a text box or something. That's not executing on the correct thread. It's going to throw an exception. Just a bunch of threading related stuff. So there's a lot of helper stuff as far as like, setting what thread you want all the stuff in Rx.NET to execute on, or setting what scheduler you want it to run on. If it's anything related to asynchronicity in .NET, I can pretty much assume that Reactive Extensions is going to have some nicety as far as getting everything set up, because I mean that's a big part of the framework is making sure that everybody matches the observable and the observer interfaces, right? And so just by nature of that, they provide a lot of utility code for kind of adapting to things like WCF and WinForms event handlers and stuff like that. So transformation operators are next. We saw a map where I was just saying, okay, well, when you give me a JavaScript event object, just instead return back the value of the text box, right? Again, it could be that you want to take a lowercase string and map it to an uppercase string. It could be that you want to take a number and double it. Any sort of I get a value and I'm going to take that and turn it into another value is going to be your map. If you've worked with libraries like underscore on the client, stuff like that, very similar. You can do things like group by. So I should mention in Rx.NET, pretty much all of the link operators that you can imagine. If you've used link queries, I guess I'll call them. they all match exactly the same. The name for name on all of those operators. You can get RX.net versions of them. So the group by for RX.net, same signature and everything that you would expect from the group by for an IEnumerable of T or whatever. So that's really nice, and that's, again, kind of goes back to the library itself is cross-platform, but it respects the platform-specific idioms of each platform, I guess. So in RX.net, he uses Link. He adheres to that interface very well. So developers who are comfortable with Link will be very comfortable with reactive extensions. Just with Link, and you're doing those queries, you always have the collection of data that you're querying right then. This is more of a, hey, when these values start to come in, query them this way instead. You can buffer them, so if you got a bunch of stock tickers, maybe you want to, just kind of bundle them up into packets of 5 or 10 or whatever, rather than emitting items one by one. You can wait and say, hey, give me the next 10 stock quotes, but don't give me any stock quotes until you've got 10. Wait till you got 10, give me those 10, give me another 10. There's window. You can say, start streaming events and give me what you've got every 5 seconds. So take 10 events the first 5 seconds, maybe the next 5 seconds there's no events and he emits nothing. Maybe in the next window of time, so window refers to window of time. So maybe in the next 5 seconds you get 3 events, in the next 5 seconds you get 2 events. So he's going to just bundle them up and send them over, so that you're not... Sometimes it's used as like what they call a back pressure technique, meaning that the event source is emitting events faster than your application can even deal with them. So you have the option to say, okay, well, instead of sending me 80 events in 10 seconds, send me the first 70 events in the first 5 seconds, and then give me the other 10 that come in last or whatever. So these are the kind of different ways of, okay, I've got a value and now I want to... Maybe I don't necessarily want to continue perpetuating that value down the pipeline. I want to change what that value represents. So scanning is another popular one too. So you want to take every item that's coming in and you want to apply a function to that. It's kind of related to map. Filtering, then we saw filter, just kind of how it was, but so there's debounce. We saw that one too. Wait and only emit an item from an observable if a particular time span has passed without emitting another item. So that was the 750 milliseconds I talked about. Distinct we did too. So don't notify me if you're going to notify me about the thing you just notified me about. If it hasn't changed, don't tell me again. That's just deduplication technique. Stuff like filter we showed. You can get the first element that comes out. You can get the last element that comes out. You can skip the first n. You can take the last or take the first n. Number of different operators there as far as like, now that I've got data coming in, which ones do I actually want to continue taking, right? So the transformation was more about, I've got a value, I'm going to do something with every single one of them no matter what. The filtering ones are more about, okay, well, if I've got this value, do I want to continue listening for those values? Combining, I showed you the merge example. There's a couple of other ones. So merge was just taking 2 streams and emitting values. No matter what value I got from what stream, I just emitted the values as they were coming through. There's ones like zip that will actually, if you've got this one emitting A, B, C, and this one is emitting 1, 2, 3, the zip's going to emit A1, B2, C3 is going to take the 2 of them and kind of pair them together and zip them up, right? So a couple of other ones there that are a little bit less common. Timing utility, so you can delay a notification off of those observables. Do is another really popular one that I use a lot. So again, when you're working with those pipelines, nothing happens until subscribe, right? The thing about subscribe, and then I'm going to talk in just a couple minutes about, the thing about subscribe is by default when you call that, he sets up 2 different observables. If you're calling subscribe more than once, he sets up 2 different observables. So if you're talking, okay, set up a 5-second timer and subscribe to that, if you subscribe to that same thing twice, you have 2 timers now, and they're each firing every 5 seconds. You're going to be slightly off, right? What you really want is you want one timer of 5 seconds that both of them are listening to, right? You want them both receiving the same notification.
So you can have subscribers in parallel.
Yep, I'm going to talk about that next. Yep. But so with the subscribe, sometimes there's things that you want to do, right? You want to do as somebody subscribes to that. If somebody subscribes to the HTTP service, maybe you want to tap it and just log in the background. You don't want it to be any part of the caller's code, right? You don't want the caller have to worry about logging the HTTP calls. It's just something you want to do in the background. So this is like a little, you can just in your pipeline just do something. It doesn't have any effect. It's just a little hook that you can get in there, get the latest value. And so if you need to like log things to the console as they're being processed through the pipeline, you can do stuff like that. So think about like if we head back to that autocomplete example. I can come in here at any point and just say .do, and so now actually I'll do it after map it. So if I do .do, I've got my my text. Maybe I just want to console.log text here. So I'm not changing the processing of the pipeline, just I want a hook in there to watch what's going on. Maybe I want to log to the console. Maybe I want to send it out to some logging service. But it's just a way to, if somebody, basically saying, when somebody calls me and is trying to set up their, or when I'm calling somebody, I guess, and getting those values back, just as part of that pipeline, I just want to do something. So there's using, that's another interesting one. So like if you've got in the .NET world, if you've got something that implements iDisposable, you need to wrap that in a using statement, right? So that it gets disposed of at the end. That's one of those things I'm talking about. But yeah, all of the subtleties of the platform, like using statements in .NET, Reactive Extensions has covered. So you can even use using statements inside of your observable pipelines. If you need to, while your stuff's processing, you need to go establish a database connection or whatever. Whatever implements iDisposable, and go do that as part of your pipeline. You can do that and be rest assured that Reactive Extension is going to clean up as you would expect it to. There's things like subscribe on and observe on, handle the threading stuff that I was talking about, and I've got a .NET example where I'll show you the threading problem. These are mostly just kind of utility type stuff to help you construct your stuff. Conditionals then can decide, so if you've got an observable that emits 10 items and then says that he's done, you can run a conditional, say were all of the values that were emitted greater than 10, and then so he'll actually take that, and so these return booleans, right? All is going to return a boolean. Stuff like A and B is going to take two or more observables and emit the items only from the first one that emits it. So if you got an observable that's listening to 3 other observables, he's only going to listen to whichever one got hooked up first. And so there's a lot of weird things, but you can think of, if you're trying to connect to multiple servers, maybe you want to take whatever one connects first and starts responding first and forget about the other 2. Again, there's a lot of things when you're learning Reactive Extension, you kind of go through and learning these operators. It's like, sometimes it's just like, who would use that? Like, why would anybody use that? But that's, there's just tons of things that maybe you can't think of a use case for, but there's tons of operators to cover just about every kind of weird situation like that. You can detect whether, again, this is kind of link related, .contains, right? If you've got a collection of items, does it contain the item that I'm asking for?
So do those only go through if the observable call is complete?
Mm-hmm. Yep. If the observable doesn't call complete on those, then you're never going to get a response back because you can't say for sure.
Can you extend the list of operators?
Oh yeah. Yeah. This is a list of probably 100. The last count that I saw, like unique operators, was something like 700, 750 or something. So these are just the most popular ones, and I'm really only talking about the most popular ones. Then some math ones. So again, like Nate pointed out, when an observable completes, you now just kind of have this collection, so you can make more informed, I guess, assumptions about them. Yeah, what was the average of all the values that came through, or what was or how many values came through, or what was the sum of all of the values that came through. So you have basic aggregation support then. And so, like I said, there's tons to choose from. Where do you start? Luckily, they've gone through and created this decision tree of when to do what. So you can kind of see some of the stuff. I want to create a new observable that, yeah, what's a good one? So yeah, these are kind of some of the weirdo ones. I want to create a new observable that completes without emitting items. So you can just do observable.empty. You need an empty observable for whatever reason. Maybe you're writing a unit test that you need to stub in. Yeah, observable.empty. You need an observable that it does nothing at all. Observable.never. You want an observable that, yeah, emits a range of integers, a sequence of integers from 1 to 10. Observable.range. 1, 10. He'll give you the numbers 1 through 10. You can do whatever you need to do with those. What else do we got? I want to emit items from an observable after transforming them one at a time with a function. You use math. Based on all the items that preceded them, you can scan. So if you want to, do any sort of processing, you want to add the last 2 values that came through, you can use scan. So yeah, I mean, there's a bunch, over 100 at least. Just little examples here of, yeah, I need to hook up to RxJS. I have this scenario. Which operator should I use? And so it's a handy resource, and there's some people have kind of broken that out onto a table and made it really easy. Here's an alphabetical list of all of the ones that they have. So these are all the ones that are just built into the framework. But yeah, you can create all sorts of your own observables and use those. So I talked about, yeah, so I mentioned a little bit earlier, if you got that timer, he's emitting every 5 seconds. If you have 2 people that subscribe to that timer, there's 2 instances of the timer. They're each firing every 5 seconds, and they're probably, I mean, they can't be firing the exact same time, right? There's going to be microseconds or whatever of difference in their firing time. And so Reactive Extension solves that by using things that are called connectable observables. So that is an observable that, yeah, is there, it's already ready, it's firing values, and you actually use the subscribe terminology, but they refer to connecting to it. So I'm going to just show an example here. So do an example without watching the console yet. So I've got an Rx observable interval, 1000. So every 1 second, and so I'm doing take 10 here. So the take 10 basically just says, I'm setting up an observable that's going to fire every 10 seconds, but I only want to do it 10 times. So I'm going to count to 10, and I'm basically just going to take my value and add 1 to it, right? So we watch that kind of go through the console. And so actually, yeah, let me finish. Ignore the commented out code. So I've got my clock.subscribe, and I'm just logging. So here I'm going to say A, and I'm going to pass a value that's coming through, right? For my second subscriber, I'm going to wait 4.5 seconds before I set up the subscription. So this one's going to fire a couple times first, right? So we're going to see it's going to come in and say A1, A2, A3, A4. After 4 seconds, after 4 seconds, but before the 5th second, this one's going to hook himself up and ask for the same thing, right? What's he going to see? So if we run that code and just look in here, nope. Okay. Why are you doing this to me, CodePen? If I hold it there, you can just watch. So you see my A, 1, 2, 3, 4, 5, then B finally comes in, but B starts counting from 1, right? because, like I said, when you're calling subscribe twice on the same observable, you're getting two separate instances of that observable. There's two counters, right? And so that's starting. He's going to say take the first one, or take the first 10. When B subscribes, he gets 1 for the first one, right? Because it's a whole new pipeline. You're just declaring what the pipeline looks like. The pipeline isn't actually created and doesn't start doing anything until you call subscribe. In this case, when you call subscribe, 2 pipelines get set up. They're both firing their own clocks, and so you're getting that same set of data. Key to that is these operators here. So the publish is the big one, and so I called this connectable observable. Publish is what takes that and turns a regular observable into what is called a connectable observable. That means is it can accept multiple subscriptions. It's going to fire the same events to all subscriptions. This guy logs in or subscribes 4.5 seconds later. He missed the first 4, and so he's not going to be able to see them. He's going to get all notifications after he subscribed. By default, the ones that were already admitted to this first subscription are going to be gone. So code panel, let me bring up my console. Use not.
Want me to turn off that?
Oh,
so
there we
can
go.
See the screen.
I'm gonna zoom in over here. So you see 1, 2, 3, 4, 5. And so after I made my change now, B's not counting from 1 anymore. B, so it has actually A gets to 6 before B finally hops on, and yep, so he's gonna get the rest of those then. So B doesn't start until 6.
We don't find.
What's that? Oh, he did. Yep, good call. So the publish takes that regular observable and says, okay, well, when multiple people subscribe, don't create a whole new pipeline. Just share the pipeline that you've created. This ref count thing starts the observable, and what that does is sorry, I probably can't read that. The ref count's going to start that observable immediately. So he's not waiting for this guy to call subscribe anymore. This starts the observable immediately. The ref count means he's going to use reference counting to, when somebody subscribes, he increments the reference counter. He says, I know that one person subscribed to me. Same thing here. Another person subscribes, reference count goes up to 2. As these 2 unsubscribe themselves, when that reference counter gets back down to 0, that observable will shut itself off. We'll call complete, and then he'll be done emitting the values. In this case, we're only taking the first 10, so by nature, it's only going to run for 10 seconds ever. But if we took that off and just let that run forever, that observable is going to keep firing events until they unsubscribe, or the program crashes, or you shut down your computer, or whatever.
Is it 20 logs there? Or
What's that?
how many lines in there?
So in this one right now, you're going to have, A is going to have 10, 1 through 10. B is going to have, 5 through 10. So 16, 5, 6, 7, 8, 9, 10, 16.
So in this case where you're doing the publishing, if you have nothing ever subscribed to it,
If I didn't publish,
if you use the publish, you never subscribe to it, nothing ever subscribed to it.
it would be running in the background. It's just nobody would be receiving the events. That's exactly right. So they refer the connectable observables, the cold observables, the hot observables. They call them cold and hot depending on which side of kind of the scenario you're on. But these are the operators that kind of help you out with that. So we saw publish, and we saw ref count. In JavaScript, they call ref counts called share. But there's 2 other ones there. There's connect, which you can call publish, and then if you say in your application, you know that you're going to have 2 subscribers, and you can set those subscriptions up right then and there. You can call publish on that observable, and then once you know all the subscribers are set up, you can call connect. And so that'll wait until basically says, hey, I want to set this up for multiple subscribers. Subscribers, go get yourself set up. And when I'm done, I'm going to call connect, which is the same thing as ref count, meaning that it starts the observable, kicks everything off, everything's actually working in the background now, except doesn't use the reference counting part. And so still your responsibility to dispose of that observable as you would. The other one there, and so we talked about this scenario just now. in the code there, B didn't get the he didn't get numbers 1 through 4, right? So there's another one called replay that will actually kind of keep those values in memory, and then if a second subscriber comes along, he'll say, okay, hey, here's the first 4 that you missed, and then from there on, he'll continue to emit the same events that that first subscription was getting. So examples. So I've got an autocomplete rx.net out here. I put it on GitHub last night. I'll send the link out for that if anybody wants to play around with that. It's a very simple WinForms application. Who loves WinForms? Raise your hand. So this is my WinForms app. It's very beautiful. Let's just get it running. So this is, yeah, the same exact sample that I had before. It's called the Wikipedia API, 750 millisecond delay there. So again, if I type my name, you can't read that because it's tiny. If I type my name, I'm going to get those things. And I hooked up another one. If I come in and if I double click on one of those, it'll actually narrow that down, right? So got my typing handler up in the text box. I got a double click handler here in this little content area. And let's go through the code. So I've got 2 fields out here just to hold my subscriptions. I've got the disposal down at the bottom. That's just for demonstration's sake. So after form 1 gets instantiated, he does his usual stuff. I've got my get results function here, and so this is equivalent to the, or roughly equivalent, I'll go through it, roughly equivalent to the call to Wikipedia API that I was using jQuery for in the JavaScript example. So I'm setting up a new HTTP client, going to Wikipedia API, blah, blah, blah. So the HTTP client in .NET has a get async method. And so practically anywhere in .NET where you're working with an async function, you can basically tap into rx.net right then and there. Just call this .toObservable extension method, and now you have an observable for that. It's beautiful. So what I'm doing is calling up to the Wikipedia API. Once I get my response back, I am so converting that to an observable. From there, I'm taking the response content and doing the read a string async, which is the biggest pain of the entire HTTP library. So when you get the response back from the call, you then have to call an async method to get the content, which is always just angering me. So I'm kind of doing, so in the other example, I used switch map in .NET. It's called select many. I don't know why, but so essentially what I'm doing is saying, once you go and get that value, go convert that to another async operation, because that's the real value that I want. So this is just me saying, take the response and give me back the content as a string. This just happens to be async, and so that's why we have to use the select many. From there, just take my response string. So this is just a string. It's a JSON array string of all of the terms that you're seeing in that list box, right? So I use JSON.NET to use jRay.parse, and it's really ugly, but it's just essentially I'm just converting that back to JSON. So I'm getting string representation of the JSON back. I need to use JSON.NET to convert that into an actual value. So I'm doing this .value string from the JArray. So he's going to return all of those to me as an array of strings. Now that we've got that far, I've got those two event methods, right? And I talked about this. So I've got my key up event. So I've got my search text box. And so I'm using this observable.from event pattern. And so that basically allows you to specify your WinForms control and specify the name of the event that you want to listen to. Using C# name of to make that nice and type safe. But so yeah, I'm basically saying, okay, go listen to key up events exactly like we did in the JavaScript example before. From there, I only want to take the text value of that text box when I get this notification, right? I don't want the whole event object and all that stuff. I just want the value of the text box. Where, and so you see here that we're using link link operators here. These aren't new operators that RxJS is providing. Again, take it and only if my text length is greater than 2, throttle it to 750 milliseconds. And so it's a little bit more verbose in .NET. If you notice, I have to use this time span that from milliseconds to 750 rather than in RxJS. He had the debounce time, which just took a number. Distinct and child change, and then select many get results. So the get results again is what's calling up to the Wikipedia API. So as all these things, all these criteria, I get a key event, take it to text, and it's greater than 2, wait 750 milliseconds, make sure nobody else fires an event, and then only if the value that I've got is different than the last value that I got, go ahead and search the Wikipedia API. Same as the JavaScript example. Doing the same kind of thing here with a different event though. So I've got my double click event was on the text box. So I'm listening to the text box, double click. I'm going and again just getting the selected item now out of that text box. Here I'm using a do. So I want to, this is one of those cases. So in my pipeline, I want to, when you double click on that, I come over here and say Joe. So if I double click on that, Joe Walsh, my text box up top populates with Joe Walsh, and then you get cool stuff like Joe Walsh discography. So I got my double click, go in and find, when I double click, I go find the selected item again. Again, I had Joe Walsh selected, double click that, and it swapped out my content. And so then I'm taking my Joe Walsh search term and calling the Wikipedia API with that instead. The one weird caveat is this one, really hairy, crappy thing. So when I've got these observables, again, this is a WinForms app. Unlike JavaScript, .NET is multi-threaded, so you've got thread considerations to take into account versus in JavaScript you can just do everything and it just all works. I've got this, so this is a function that takes an observable. It's just a helper function so that I can process all my stuff in the same way. So this is going to take my observable and he's calling this .observe on synchronization context.current. That's something that is required that if you're launching something from the UI thread and you want to update something like a text box on the UI, you need to make sure that all that stuff happens on the same thread. And so this is, I couldn't really tell you what the synchronization context at current means, but essentially it means that, whatever thread that this is being hooked up on is the thread that you should execute the callback in. So then I'm observing on that then, so when I go and I try to clear my list of items out of the text box and now add the new items to that text box, everything works just because it's on the UI thread. So I haven't done a whole lot of Windows Forms programming, but that was, I remember even college being tripped up by that stuff when you try to do background processing and go back and update the UI, just pain. I think that's pretty much it. I've got a couple sources out here. So the Reactive extension, so reactivex.io, they've got great documentation, marble diagrams for everything. They got the full list of all the stuff out here. They've got so there's stuff filter. The cool thing about these is you can actually click and drag and reorder and see what things would look like if the events emitted in a different order, So again, the last, only take the last one. So when it completes, go take the last one. If 3 becomes the last one, then 3 is the one that's going to get emitted at the end, right? Just really, especially when you're dealing with a new operator that you haven't worked with, a lot of times it's really hard to wrap your head around it. And so again, these marble diagrams, pipelines from top to bottom. He emits a 3, 2, 4, 1, then says he's done. Last is going to say, okay, well, he emitted all of these. What was the last one to come through? And emit that instead. So if you got something that might be emitting a bunch of events, maybe you're, listening to a sensor for 3 seconds, a temperature sensor for 3 seconds, and you just want to take whatever the last value out of that sensor coming back was after 3 seconds. It's hard to think of a lot of like asynchronous use cases because so much of the code that we write is synchronous, but yeah, it's things like Internet of Things and sensors and all the new data sources that are out there. I mean, there's so much data out there and things you can listen to and monitor. You're going to see a lot more of this sort of programming kind of becoming more prevalent. So there's a cool example repository out under the RxJS. He's got a bunch of examples here. I actually came out and stole the Wikipedia example from here. You can see there's the Wikipedia, probably looking tiny up in the moment. Wikipedia, I just cleaned it up a little bit. It's kind of outdated, hadn't been updated since 2015, so some of the operators had been renamed since then. And then the 2 books that I had up here, stole some info from them. That's pretty much it. Any questions?
Yes.
Ask away.
And what the volunteers refer to?
You're always the first one. Your first one,
Sorry,
last
I
one.
missed. You were talking about threading when I came back in, and darn, that's when you have multiple subscribers for one observable.
Mm-hmm.
Maybe it's platform dependent, but if they theoretically both fire, does it serve a separate thread for each one, or does the system essentially iterate through them?
So that's a good question. If you set it up the way that I just had it set up, where you're doing the observe on and synchronize. So here I'm using the synchronization context at current, so the current thread for the synchronization context. If you do that, he's always he's gonna process everything on the same thread, right? So from there, I mean, unless you handle the threading yourself, I don't know that he makes any.
That's usually what they do.
Yeah, and so so there's more niceties in there, and RX.net is definitely. I'm definitely weaker on the RX.net side than RxJS.
So once you start a new thread to handle this, it's going to essentially go through them in order. I suspect. Pardon me, I'm an older guy, different time, but go through handler 1 or subscriber 1.
Oh,
complete that, and then
you're asking which subscribers are going to be notified for. So if I have 3 subscribers, will they be notified in order? Is that what you're asking?
Well, I'm saying that if you don't start off separate threads, they're not going to be called simultaneously.
Right. So if you're doing one of the observables, where you've got multiple subscribers, but it's only being set up once, so they're all receiving the same events. So you should be receiving all those events on the same thread.
Okay.
Meaning callers 1, 2, and 3.
You can't do it all simultaneously in one thread. It will have to step through them.
Right.
Okay. Or wait until subscriber 1 is done and returns control.
Right.
Et cetera, et cetera.
Yep.
Okay.
Any other questions?
You get a specification on the course. Sometimes there could be something that gets updated to you. I haven't seen, like in most cases, another thing I was going to mention to folks too is I've used it for one project and a couple of people, which is the Reactive UI, which is built on top of RX and it's for
Anything else? Like I said, I've got code out on GitHub. I'll put the slides out on Meetup. Everything. Yeah, there's a couple code pen links that I had. I think that's it. So if nothing else, we're good to go. Thanks for coming. We'll see you in February.